All right, let's talk about something we've all been through. That moment of pure frustration when your HPLC run goes south. Well, you're in the right place. Think of this as your quick and dirty guide to figuring out what's wrong and, more importantly, how to fix it fast.
Oh, you know that sinking feeling, right? You set up a perfect run. You walk away and you come back to, well, garbage. Maybe there are no peaks at all or the pressure is all over the place. It's enough to make you want to pull your hair out, but honestly, the fix is usually way simpler than you think.
Okay, so what's the first rule of HPLC Club? It's simple. Don't panic. Seriously, take a breath. The key to solving pretty much any instrument issue is just to be logical and go one step at a time. And the most logical path? It's the one your sample takes through the machine.
And to help us out, we've got this. This right here is going to be your new best friend at the lab bench. It's a cheat sheet, a visual map that lays out the whole troubleshooting process. We're just going to walk through it together, section by section.
So, let's dive in. The absolute golden rule, the one thing to remember is this: follow the flow path. You start at the very beginning with your mobile phase, and you just methodically check each part in order: the pump, the injector, the column, and then finally the detector. This way you're actually isolating the problem, not just randomly guessing.
Okay, so let's start with the most heart-stopping problem of them all. You get absolutely no signal, just a flat, dead line. It feels like a total disaster, but trust me, the cause is almost always something super simple.
9 times out of 10, a no-signal issue is a facepalm moment. Ask yourself the simple questions first. Is the lamp even turned on? Are you on the right wavelength? Did the autosampler actually fire? And the big one, have you got air in the pump? A quick check of your settings and a good pump purge can literally have you back up and running in minutes.
All right, moving down the line. Let's say you do have a signal, but your system pressure is going bananas. Well, our next stop is the pump. This thing is the heart of your HPLC, and weird pressure is the classic sign that something's up with it. Now, pressure problems really only come in 2 flavors. You've got high pressure, which basically means there's a blockage somewhere, like a clogged filter or a column that's given up. Then you have low or cycling pressure, which means the opposite, something's escaping. That usually points to a leak from a loose fitting or, yup, you guessed it, air in the pump heads messing with the flow.
So let's tackle this methodically. First, do the easiest thing imaginable. Check and tighten all your fittings. If that doesn't fix it, purge that pump to get any air out. If the pressure is still too high, try flushing the system. And if it's too low, it's time to take a look at the pump seals and see if they're worn out and causing a leak.
Okay, we're moving downstream again to the injector and the column. This is the business end of the HPLC, where the separation actually happens. And if there's a problem here, you're going to see it in your peak shape. If your peaks look wonky, the problem is almost definitely in this section.
And here they are, the 3 horsemen of bad chromatography. You've got split peaks, fronting peaks that look like shark fins, and of course the one we all know and hate, tailing peaks. Each one of these shapes is telling you a different story about what's going wrong inside your system. So, here's your game plan. If your peaks are splitting, it's probably a physical problem, like a void in your column, or maybe your sample solvent is fighting with your mobile phase. If you've got fronting, you've almost certainly just overloaded the column. That's an easy fix. Just inject less or dilute your sample. And for tailing, the most common headache of all, that could be anything from dead volume from a loose fitting to some weird chemistry happening on the column.
We're on the home stretch now, at the very end of the flow path, the final output. Because even if your pressure is perfect and your peaks look beautiful, you can still have issues with a noisy baseline or peaks that just refuse to show up on time.
So here, we're looking at 2 different things. A noisy, fuzzy baseline, that could be those pesky air bubbles again, an old lamp that's on its way out, or even just some cruddy mobile phase. And if your retention times are drifting all over the place, well, that screams instability. Check your flow rate, make sure your temperature is steady, and, say it with me, check for air in the pump. You know, we've spent a lot of time talking about how to fix problems, but an ounce of prevention is worth a pound of cure, right? Being proactive is always the best strategy. And it's also really important to know when you're in over your head and need to call for help.
So how do you get off this crazy troubleshooting roller coaster for good? The answer is just consistency. Building a simple maintenance routine into your workflow can make a huge difference in how reliable your instrument is.
This checklist right here, this is pure gold. Every day, just do the simple stuff. Check your solvent levels, look for any drips. Once a week, give the system a good flush to get all the gunk out. Once a month, take a quick peek at the pump seals. And once a year,
Let the pros come in and do a full PM. It's the best thing you can do for your instrument. But hey, let's be realistic. You are not a service engineer, and you can't fix everything. Sometimes you've tried all the logical steps, and the instrument is just not playing ball. Knowing when to stop and call for backup is just as important as knowing how to troubleshoot in the first place.
And these are the big red flags. We're talking about major issues like persistent sensitivity loss on a mass spec, internal leaks you can't even see, or complex errors where the LC and the MS just aren't talking to each other. That's when you pick up the phone. And of course, for your annual PM or when you need certifications done, that's definitely a job for the experts.
So there you have it. It's not black magic, it's just logic. By following the flow path and thinking it through step by step, you can honestly solve the vast majority of HPLC issues yourself. So keep this guide handy, trust the process, and the next time your instrument starts acting up, you'll know exactly where to start. You got this.